Welcome to the Beyond 3D podcast, where we explore all things 3D and the important role that 3D data plays throughout the manufacturing process, driving decisions throughout a product's lifecycle. Here, we talk with industry analysts, business owners, developers, and industry influencers, and hear real stories that you can relate to and learn from, and know which trends and technologies apply to your business. So join us as we go beyond 3D. Welcome, everybody, to another episode of Beyond 3D. We are here today with the special guest, Chris Jones, He's President and CEO of Actify. Hi, Chris. Welcome, and thank you for joining us today.
Hi, Angela. My pleasure.
And from TechSoft 3D, we have Dave Opsahl, who is Vice President of Corporate Development. Thanks, Dave, for joining us again.
You're quite welcome, Angela. Hi.
Hi. So, Chris, why don't you just spend a couple minutes telling us a little bit about yourself and Actify, and maybe just a 30-second definition of discrete manufacturing in case some of our listeners aren't familiar with that term.
Sure. So several questions there. So starting with Actify. Actify have been around for 20 years now. Our anniversary is coming up this December. And we're mostly known for our CAD viewing software, Spinfire, the ability to view 3D models and interrogate those models without a CAD system being present. But in recent years, we've expanded that footprint to not only allow customers to view 3D CAD information, but to also view all of the associated metadata that goes along with that 3D information. Personally, I've been in this industry an awfully long time now. I was working it out the other day. It's over 30 years. So I've worked for most of the major players. Yeah, I know. It's an old photo up there, so I don't look that old. But yes, I think I'm considered an industry veteran, and I've worked for most of the big CAD companies and also been involved in their PLM, PDM strategies as well. And for a time, I was also, I guess, a management consultant to some pretty prestigious manufacturing companies like Seiko and Mazda in Japan. So that gives you a flavour for my background. And then when it comes to your question about what is discrete manufacturing, to keep that definition simple, I always think about that as people that manufacture things, something that is physical that you can actually hold, unlike the process industry, which is oil, gas, utilities, etc. Discrete manufacturing for me is anything that is a physical object. So that's how I would describe it.
Okay. And so in 30 years, you've seen a lot of changes happen. So what, in your opinion, has been either the most surprising or maybe the most exciting thing for you?
That's a good question. I think when I take a step back and look now, and this is what really surprises me the most right now, is that in those 30 years, I've seen a massive change, obviously, in computing and computer software and the use of software by companies. But I actually believe now the change, the rate of change, is probably bigger than at any time in the last 30 years. And, you know, we've gone from, I remember writing my first program and using punch cards to get it into the CPU. But now I think there's an absolute tsunami of change coming, and you could call it a digital revolution. But I believe the rate of change now is greater than at any point in the past 20 or 30 years. And just to sort of try and qualify that with some numbers, today the estimate is that we're producing 2.5 quintillion bytes of data daily, and that's up from 2.4 last year. And a quintillion is 1 times 10 to the power of 18. That 80 to 90% of all the world's data has been created in the last 2 years. And you know, I can see that trend just accelerating because the Internet of Things explosion hasn't really started yet. I mean, current estimates say that there's between 10 and 12 billion connected devices worldwide today, and approximately 2 billion were added in the last 12 months. The estimate is that number will probably be 50 billion by the start of 2020. So if you think about the information that all those connected devices are creating, or the data that they're creating, and how best we can use that, then clearly companies need to have a step change in the next couple of years to make the most of that information that's being provided. And the other thing is that a few years ago, that data was really only coming from, in my opinion, how would I best describe that? Sophisticated machinery. You know, people have heard stories about how GE and Rolls-Royce collect data from a jet engine so they can anticipate maintenance schedules. And the whole car industry with the autonomous car, you know, a car like that is actually generating about a gigabyte of data per second. But it's not just about big things anymore and complex machinery. Just an interesting aside, I went out a couple of weekends to buy a padlock. I was intrigued to discover, you know, there's no combination lock on a padlock anymore. There's no key involved in a padlock. It's a smart padlock. You control it from your phone.
So you can't even buy a regular one or an old school one.
I think you can, but you have to find old stock. You know, the trend is for a smart padlock, you know, and you couldn't think of a more simpler device, really. And so, you know, my belief is that with all of this data, we've got to start making better use of it. And from manufacturing companies, I think they're seriously behind the curve on how to make best use of the data. And, you know, a good example would be of another industry. There's a grocery store in England called Tesco's. They have a couple of stores now, whereas you go in the entrance, you pick up your trolley and your cart, and you swipe your loyalty card in a card reader. And then as you're walking up and down the aisles, it knows two things. It knows who you are, and it knows where you are in the store. And it will flash up marketing offers to you as an individual. Mm-hmm. So if you're new, you know, if you've a new mum, for instance, just had a baby, as you're going down that baby aisle, it will flash up offers about diapers, etc. If you're a middle-aged gentleman like myself or Dave, it probably flashes up offers on red wine as you go into the wine section. But that's, you know, that's a really clever use of big data. And overall, the stats and the estimates are that only 10% of all this data that we're collecting is being A, collected and then B, collated. But in the manufacturing industry, we're down at 1 or 2%. So I think there's opportunities in all industries, but particularly in manufacturing companies, because, you know, they're also producing a lot more data from their products on how it's used and so on and so forth. And, you know, warranty issues and wear and tear, etc. So they've got all this information, but I just don't think it's being used. And coupled to that, what's also happened is that I think engineering as a profession has certainly not been the favourite occupation for the brightest and smartest coming out of universities. And there's a huge shortage of engineers worldwide, and particularly in the US. I mean, the estimates.
Yeah, I've been talking about that for a while.
Yeah, you know, I think probably 600 to 700,000 engineers down on where you guys need to be. So the challenge, you know, going forward, I think, is this. You've got these two opposing forces that need to be solved. You've got this wealth of information that is being produced, and then how best to use it with far fewer people. And I think, you know, going forward, this is going to be a real challenge for the industry in general. And, you know, as I said before, it's not just big, sophisticated products, and consequently not just big organizations. It's also small to medium companies as well that face this challenge of how best to use this information, because if they don't, somebody will, and somebody will gain a competitive advantage from it, I'm sure.
So I can't help but wonder if, you know, some of the numbers that you threw out, were astronomical numbers, right? We all know that there's a lot of data out there, but when you put a quintillion number on it, and it's hard to comprehend just how big that is. I can't help but wonder if manufacturers are slow to adopt or slow to do something with it because they're just overwhelmed and don't know what to do with that if they had that kind of data. Do you think that's part of it, or?
No, I think you're absolutely right. I think this comes down to one of the reasons why not much data has been, collected and sorted, because it's a question of, okay, what do we do with it when we've got it? There's the lack of engineers, and there are also manufacturing companies are going through their own quiet revolution, I think, as well. In the products they produce are also becoming more and more sophisticated, so they're trying to keep up with that trend as well. I mentioned the simple padlock. I was with a customer a couple of weeks ago that manufactures car bumpers, and 5-10 years ago this was just a big piece of plastic. Today, it's a big piece of plastic that has lane sensors, it has cameras, it has reversing and forward collision cameras and sensors, etc., etc. And so they're really fighting a battle, I think, on several fronts, and this is one of the reasons that they are slow to adopt. That said, I think I've attended a couple of conferences in the last 6 months. And I'm seeing more and more people ask the question, this is clearly something we need to do. How do we embrace this information that we're receiving? And once we've embraced it, how best to understand what we're receiving? Because I also believe that an awful lot of the data that is being collected is, quite frankly, noise. And you're looking for the 1% that is truly meaningful, and then that comes down to software companies like us trying to filter that and make better use of the information that people are receiving.
And so it's funny, in this conversation we might think that manufacturing has been slow to adopt technology, but in fact I think the building industry has been even slower to adopt, especially the use of 3D technology, 3D design, viewing 3D models, things like that. And Dave, would love your perspective on this, because you've been in the industry for a long time as well, and how you saw that adoption of the use of 3D data in manufacturing in a very intelligent way, and lessons learned from that adoption process to, okay, guys, that was the first wave, right, of really sophisticated technology. Or some people will say it's the third wave, actually. And now you have, let's say, this fourth wave where, okay, now we have these other things like IoT and AI and AR. What lessons can customers learn from, the adoption and incorporating the use of 3D data into now incorporating some of these other technologies?
Well, I think that the complexity that Chris talked about of trying to deal with the noise of the data coming through is probably more prevalent in discrete manufacturing than it is in the building industry. In some ways, the building industry was a little bit more aggressive in the way that it used, 3D in some respects, but it's also a much, my brother who owns a structural engineering company would probably, kill me if you heard me say this, but it's a much simpler problem than, say, trying to figure out if I'm a supplier of suspension systems, how what I do integrates into the design of the car that Audi or Volvo is making. And so, that problem of how to sort of filter out the noise and get to the data that has meaning, I think is a bigger problem for manufacturing. And, one of the ways that we're starting to see more activity and from that lesson learned is that, well, if you're dealing with something that fundamentally is a spatial object, something that exists in space, the way that Chris was defining discrete manufacturing, why not use the 3D data as a principal way to navigate that data and let that help you figure out where the noise is coming from, or at least maybe even not presenting you with the noise. So, for example, if what I'm looking at is a way to be able to understand the material properties of a particular component in an assembly of a suspension system. Why do I need to know what the rest of the car looks like? Or why do I need to know anything about the other parts of that information? Why do I care about feed and speed data that's coming from an NC machine if it's not related to, the particular thing I'm looking at? There's a lot of decisions that can be made, but at the end of the day, somebody, a human being of, one sort or another is the one that has to look at that information. So the context of who they are, what their role is, what kind of data matters to them is a way of being able to filter out that noise and then allowing them to see that in the same way that the designer intended it, instead of looking at rows and tables of data, I think is another way you can be a lot more effective filtering out that noise.
I think actually Dave brings up an excellent point as another challenge that's facing discrete manufacturing companies, is that you've got all this information coming from hundreds of different data sources, and which is, the same could be said for the retail banking industry and so on. But the big fundamental difference is that discrete manufacturers make something that's typically a 3D object. So you've got this 3D database that over the years has grown in the amount of data that is being stored in that 3D database. And today, to make use of it along with all the other information is a unique requirement for manufacturing companies. And Dave mentioned rows and columns of data. I think that is another fundamental weakness of, in fact, the software industry, and this is something that Actify has been working on hard, in to produce a foundation or a solution that allows somebody to view information from multiple different data sources, including 3D. Because unless you can mash the 3D data together with this other information that could be material, it could be cost, time, warranty information, etc., information that's coming from the shop floor via sensors or wherever, unless you can include 3D in that equation, it's almost meaningless. And I think that the software industry and people that provide solutions to manufacturing companies have some catching up to do, because, if I look at most PDM, PLM systems and ERP systems that are out there in the marketplace today, 99.9% of them are using based on a foundation of a solution that was invented by Ted Codd from England 50 years ago, and that's a relational database. And with the rate of change and the amount of information coming into an organization, and that information that needs to be collated and diced and sliced and viewed and made sense of, a relational database, quite frankly, just doesn't cut it anymore. You have to go to a graph type architecture. And, so we've taken the lead from people like Facebook and other social media companies in that our solutions are now built on top of a graph database, which allows you to view and interrogate information that's coming from multiple different data sources in a very flexible way, because, you just can't do that with a relational database. And it also allows people to search in a far more intuitive manner, because relational databases are very good at short, fat searches, how many people over 50 live in North London, for instance, but they're not very good at things like, have I manufactured anything that looks like this before? If so, where did I manufacture it? Who was the engineering charge? What facility did I make it in? Have I still got the tooling? What was the lead time? Those long, thin queries that engineers tend to do are also not suited to the old-fashioned relational databases. So you can see how you've got all these different moving parts that, it's a challenge. It's a challenge, certainly for companies like Actify to produce solutions that satisfy that need, and also for manufacturing companies to understand how best to use that information once it's presented to them.
And can you think of, and maybe you have a customer that's doing this, or can you think of a manufacturer, either large or small, that has started to tackle this challenge and is headed in the right direction? I mean, probably they have not solved it completely, but they are headed in the right direction, and it's an example that maybe other manufacturers can follow.
Sure. I mean, I can go both ends of the spectrum. So a small company we have a very simple business rule that if the price of the raw material of the component they are manufacturing goes above 30% of their quote price, their profit margin starts to be eroded. That's quite a simple business rule. Now, today, how do you know that's happening? It's very difficult to collate information from 3D CAD to get the size and the volume of the component, the material information, the price of the raw material in the open marketplace, the price that was quoted to the customer in the first place, and then apply that business rule. Today they typically don't know until it's very late in the project. It's then difficult to tell the customer, oh, by the way, we want to put the price up, because you're collecting information from 3, 4, 5 different data sources and then joining the dots manually. And that's something that we have done for a customer where instantly, once the engineer saves the 3D CAD file, it converts in, using TechSoft. We extract the metadata, the volume, we compare the quote information, we apply a business rule, and if it breaks that business rule and there is an erosion of profit margin, we email the COO in this case. So that's, I think, a good, simple example of how we are collating information from multiple different data sources, mashing it together to present an actionable alert to somebody. At the other end of the spectrum, we did some work for a very large UK automotive company, and that was looking at their the whole car program, basically. So we would pull up the car platform, the model year, and we could immediately alert an engineer if there was an issue of a pre-used sub-assembly that they were planning to use, perhaps the rear suspension system from the 2016 model in the 2018 model, if there was a warranty issue. Again, this was collating information from CAD and issues management database, their warranty database, and mashing that information and again presenting it to an engineer so that he could take action. Again, previously, that timeline from there being a warranty issue in the field getting through to a design engineer that was designing a car for 2 years hence was protracted, to say the least, and probably they were going to miss those release gates. So just a couple of relatively simple examples.
But it's good to hear that it both a small manufacturer as well as a large manufacturer can implement these kinds of solutions, because I think oftentimes, and Dave, you can attest to this, that the small guys will say, yeah, I would love to do that, but I don't have the budget of a big guy to implement this, huge enterprise system. But, as the technology becomes more sophisticated, it also becomes more accessible, would you say?
Yeah, I think that's another lesson learned. I mean, Chris was talking about the pace of change or the rate of change, the technology. That's made it accessible to small and medium-sized companies. And so from a lessons learned standpoint, I think, not so many years ago, small to medium-sized companies could afford to kind of not really spend a lot of time thinking about, do they need to solve problems like the one Chris was describing. They've always had the problems. They've just considered that, the solutions were only accessible to, the General Motors, the Boeings, or the other large manufacturers out there. But the technology has changed so fast and is continuing to change at such a rate that it's now produced tools like what Actify does that make it accessible for those, small to medium manufacturers to do that. And I would say that beyond just it being accessible now, it's becoming a way that they can grow their business, sometimes at the expense of those larger companies, because they're much better positioned to respond when there's a change like that. And so I think we're going to see more and more of that pressure, and I think it's a positive pressure. It's going to, help manufacturing continue to be competitive, regardless of where you are in the world.
And with that, I think we're at our time. And so we just have one last question for Chris. So Chris, we ask all of our guests at the end for a call to action or a bit of advice for our listeners. So if you could have one bit of advice or want our listeners to go out and do one thing after listening to this podcast, what would you ask them to do?
I think if you're a company that doesn't have a digital strategy on how best to use the information that's being produced now, that you have within your organization, the historical information and the information that is almost certainly going to be flowing into your organization over the next couple of years, you seriously need to sit down and think about it. And this is a big strategic initiative, and it needs executive input, I think, on how best to move forward to make use of data going forward, because it's going to be a competitive advantage for sure.
Agreed. I think all of us can agree on that. And we will definitely include a link to Actify in our show notes, so that for those of you who will be starting to create a digital strategy or modifying your existing one, definitely encourage you to look at Actify as part of that solution, as well as TechSoft 3D, of course, Dave. Don't worry, I would not forget to mention us. So thank you both for joining us. I think this is a really great conversation, and I hope that our listeners found it helpful. And if you have not subscribed yet, to our listeners, if you haven't subscribed yet, please do so on iTunes or on SoundCloud, and share this podcast with your colleagues and friends, other folks in the manufacturing industry. And we thank you very much for listening. And until our next episode, have a great day. Thank you for joining us on the Beyond 3D podcast, hosted by TechSoft 3D. Be sure to subscribe on iTunes and leave us a review, or subscribe on SoundCloud. To listen to past episodes or learn more about TechSoft 3D, visit www.techsoft3d.com/blog. Send us comments and suggestions at info@techsoft3d.com. Thanks again for listening, and we hope you'll join us again on the next episode of Beyond 3D.